So solving these radical equations, these first couple examples, the radical is already isolated. We're ready to square both sides. When I square the side with the radical, that just gets rid of the radical sign. I don't write x squared. That's the radical sign now is gone. And then 9 squared is 81. And if I check it, the square root of 81 is 9, of course, right? So x is 81. It's good. So in number 2, the radical again is already isolated. So I square both sides. On the left, all that does is make the radical go away. So now I have m plus 5. On the right, there was no radical, so I actually do 2 times 2 is 4. Now I'm to solve the remaining equation. So now I subtract 5 on both sides, or I just look at it and go, oh, that has to be negative 1. So I have m is negative 1. So then if I check, if I have negative 1 plus 5 underneath, that's the square root of 4. The square root of 4 is 2. Yeah, it checks. So far, not bad. We cannot reach in and subtract the 5 while the 5 is under the radical. So we have to get rid of the radical first. Remember, it's like a square root. It is square root. So square root, the opposite operation is squaring. But whatever I do to one side, I got to do to the other. That's why it becomes 4. It doesn't stay a 2 over there. So radicals still by itself in 3 and 4. So I'll square both sides. So I have 36 is equal to 4y. Again, the side with the radical, don't change what's under there. It's just out of the radical now. And then do whatever you have to do to solve that equation. So now I have 9 is y. And if I check, 4 times 9 is 36. And 6 is the square root of 36. Life is good. Number 5. Again, the radical is by itself. I'm going to square both sides. On this side, radical goes away. On the other side, 13 squared, so not 26, 169. Then I need to solve a 2-step equation. So after I get rid of the radical, it could be several steps, just depends on what you have. But they would be steps that you already know how to do. 34, I think. And if I plug that back in, 34 times 5 is 170 minus 1. So the square root of 169 is 13. Yes, true. So far, all of the examples I've shown you have had the radical already isolated. It was already by itself. Notice on number 7 that now that minus 7, the radical is not extended over that, which means it's not under the radical. Before you square both sides, you have to have the radical part by itself. So we are trying to get this by itself, so I'm going to have to add 7 to both sides to get rid of the minus 7. And then negative 6 plus 7 is 1. Now the radical is by itself. I can square both sides. So I get x is equal to 1. And if I check, the square root of 1 minus 7, so that's 1 take away 7 is negative 6. That's true. So for some of them it may seem like, I don't know why we're doing the check, because it's always true. There are times that it's not. Okay. So for number 8, what do I need to do to get the radical by itself? No. So don't just tell me the answer. What do I need to do to get the radical by itself? So divide by negative 10. So it's like this. If this were a giant x, negative 10x does not mean x minus 10. It means negative 10 times. So when we have this, we need to divide both sides by negative 10. Then we get 5 is radical n. Then we square both sides, because now the radical is isolated, to get 25. And if I check it, the square root of 25 is 5, and negative 50 is equal to negative 10 times 5. So it does check. It's not extraneous. My solution is good. What do we need to do to get the radical by itself in number 9? We need to get rid of the 1, right? We've got to move the 1 over. And then we have this minus sign. So we would need to divide by negative 1, because that's like negative 1 times this. Then I have this is equal to negative 3. Then I can square both sides. I get x plus 2 is equal to, what is negative 3 squared? Be careful. 9. 9 positive, right? And then when I subtract 2, I get x is equal to 7. Now, when I put that back in, 1 subtract x plus, or 7 plus 2 under the radical. 7 plus 2 is 9, right? What is the square root of 9? 4. Is 1 subtract, or 3, duh. Is 1 subtract 3 equal to 4? No. So this is extraneous. And if there's no other solution, then we would have to say no solution. Sometimes we're going to have 2 potential answers, or in Algebra 2 you're going to see some of these that have 2 answers, and one of them might be extraneous. So number 9, the answer is extraneous. When I go back and check it, it does not work. Kind of the problem with that is during the work, when you see the square root is equal to a negative, when we are doing these, we are always using the principal square root, the positive square root. And so since that was equal to a negative, that's, sometimes you can foresee that that's happening, but if not, again, doing the check. So in number 10, first I would get the radical by itself by doing what? So first it's like I'm treating all this as a giant X. Divide by negative 8, yes. Then I have radical, under the radical, 2c plus 3 is equal to 5. Then we'll square both sides. The one under the radical is just now free of the radical. The other one actually gets squared. Then we solve, in this case, that 2-step equation. So 2c is 22, c is 11. And if I check 11, this would be 22 plus 3. So that's negative 8 times square root of 25 is 5. It checks. It works. It's good. So first we get the radical by itself. Could be adding, could be dividing, could be multiplying, could be two steps like number 9. Then we square both sides to get rid of the radical. Then we may have one, we usually would only have 1 or 2 steps. The ones with 2 radicals might seem worse, but they're actually easier because the radicals are isolated. There's nothing hanging on the outside of them. So we just start out by squaring both sides, and it just becomes r equal 42 minus 2r. I just have more than one variable. So I got to get my variables on the same side. And then divide to get r is 14. Now, when you try to check this, you might not like it because this says the square root of 14 and the other side is like 42 minus 28. It's okay that they're not perfect squares. The square root of 14 is equal to the square root of 14. Like, I don't have to like put that in and find decimals. So when it's a radical on both sides, basically you're just going to end up getting rid of the radicals at the beginning and then solving a multi-step equation. You can have these where you have to factor, but you would have to have an r squared. Let's see if I've got some, or an x squared or whatever. That will not do that. Sure, some of you are curious about the one with a fraction. Multiple. And so I could do that. That's going to help me get the radical by itself. So if I multiply everything by 3, then I would have 33 is equal to, no fraction here anymore, plus 21. Then I need to move the 21 over, or I could have done that first. Then square both sides. No, multiplying by 3 took away the fraction. The 3 in the bottom of the fraction was not inside the radical.
So you don't actually multiply the 8.
No, because if I'm, like when I multiply that by 3, it's just getting it out of the fraction. And then when I square both sides, I have 144 is equal to 8h. And then what is 144 divided by 8? 18? Is that right? No.
Yes.
Yes? Not in my memorization list, obviously. Okay, so the first, that is not the only lesson that I will teach tomorrow, but for the first 30 minutes tomorrow,